All right, we are ready to go. So I'll turn it over to you, Joel, and off we go. Thanks everybody for joining us today.
Yeah, and thanks Nick for doing all the legwork on setting this up. So I normally like to put we'll do an introduction here in a second, but I normally like to put the abstract as one of these slides because we are live streaming to YouTube, and after the event, the live stream will be available on YouTube and also through the Meetup site and the slides as well. So we'll have that content to you. So I won't read through but this is essentially the abstract that we had in the meetup, and thanks everybody for joining here today. So I'm Joel King. I'm a distinguished engineer at Net Craftsman, a Blue Ally company, uh, former CCIE, and I've worked with Bob and Nick and quite a few people on here in the past, and I see Terry Slattery just joined here as well. So thanks for everybody. So we're going to have an open dialogue here today. I'd like to get people's perspective, as I was saying here as we started. I mean, these meetups, I'm facilitating it here today, and I have some examples and kind of lead the presentation, but I would like to hear people's thoughts and ideas, and we'll talk a little bit about our code samples here. So our agenda today, and we're going to wrap up here probably in about 45 minutes or so. So we're going to first talk about what is Pangea. A couple of slides here, and I do have Pramod here from the Pangea on the line here. So we have an expert on here that's able to kind of fill in if we have any questions, or I can provide more information. I'm going to show you Ansible content collection that I wrote that includes an Ansible module that interfaces with the Python SDK, Pangea Python SDK, to do user intel and URL and domain reputation. And we'll see here in a second that there's other features of Pangea that I don't cover in it, but I put this together pretty quickly. It's not a complete solution, but it'll give you an idea what you can do with it. I'm just going to touch briefly on hashes and ciphers used in routers and switches because kind of just a refresher on it, and see how we can address perhaps the security posture of credentials that we put in those switch configurations. We'll talk about a way of doing a pre-check of usernames and password breaches to see if the username and password that you might be using in your network or in your organization anywhere has been exposed to a breach. And we have an Ansible playbook that prompts you to do that. And then I have a couple of use cases that we can demo. And I can demo them here on my laptop, but also have screenshots of it. I wrote some Ansible filters to parse iOS configuration and pull out some of the information that we want to feed into and do breach checks on, and they're available. I'll give you the link here in a minute. Another use case about using your source of truth, Netbox, to be able to integrate with these with this content collection and these filters so that you can check the security posture of that. And then I have a use case that really was what I started out with, was this concept of how you integrate Pangea into an onboarding process. And then we'll just wrap up with an open discussion. So please feel free to ask questions. Please feel free to make comments at any time. It's an open dialogue, and we want to encourage that. So what is Pangea? Pangea has been out of stealth mode here for about a year. It is a cloud-based security platform that you can leverage APIs for to do various security services. So think about it this way. We have cloud providers that offer compute, storage, database services, and AWS obviously has a lot of different services there. Think of Pangea as a way of providing security services, much like a cloud provider will provide cloud services, and it is a software as a service or platform as a service, and it goal is to focus on application developers, and I don't consider myself an application developer, but because it has Python SDKs and other language SDKs, you can use it from whatever you can call Python or your SDK from. Pangea.cloud is the web page. So if you're looking at it offline there, you can go to Pangea.cloud. And one of the things that's interesting to me, so just a little history here, the co-founders of this, Sorb and Oliver Fredericks, also founded Phantom Cyber. So I worked with Phantom Cyber in 2016, and at that time they had an app development contest for Phantom Cyber, and I was fortunate to tie for first place in that app development contest with some Phantom Cyber apps for F5 and Meraki. And one of the things that I liked about that platform was the fact that it had a community edition. So you could go in and use use all of the functions of Phantom Cyber to be able to develop against that. And they were very open about enabling the community to be able to adopt it. And even more recently, just back in May, Phantom Cyber is now Splunk SOAR. Back in May, I actually incorporated Splunk SOAR into an Ansible, event-driven Ansible that we did for the Cisco Federal Innovation Challenge, and integrated that as a security use case within event-driven Ansible and using Kafka as a message bus. So one of the things that I really like about the folks that are behind Pangea is the fact that it's free to get started. So they'll give you a $5 credit on your cloud platform. And I've been using it to develop against and doing a lot of API calls for testing. And I haven't exhausted that monthly credit. I still think about have about half of that. So if you want to develop against this, if you want to take the code that I've published here as a guide, you can do that, and you can go out and explore all those services that are out there in Pangea.cloud. So if you go there, you can do that. So that's one of the things that I really like about this approach, this community approach, this community edition, being able to get people involved in using the platform. The barrier to entry is very low, and that's certainly, in my opinion, is a good thing. So some of the services that you'll see if you go into Pangea.cloud: compliance, data protection, access, intelligence, and detection. I'm focused on the intelligent piece. So I have not worked with all of these, but I have focused on the intelligence piece because the use case that I was particularly interested in fell into that realm, and I thought that was an easy way to get started. So there's an API reference for all of these different services, and the concept of where the data comes from for these security services is through, for the intelligence piece, is through a series of providers. So Digital Element, CrowdStrike, Domain Tools, SpyCloud, Reversing Labs. Depending on what reference that you're using, there may be one or more providers that back end this service where that data comes from. And the databases from some of these are quite extensive. And some of these databases people might refer to as being data in the dark web. And I thought it was very interesting when I was doing testing to be able to use different user and password combinations, and I was amazed at the results that I saw. So I used to entertain some of my friends by putting in their email addresses and usernames and then sending them a chat message and said, "Hey, this password's I know what this password is because I know a little bit about you, and I know where that password that you used came from." So what I have tested here and working is the URL intel. It allows you to retrieve information about known URLs and provide a reputation for a URL. We'll see an example of that. Domain intel, so a domain service. So it gives you an idea whether the domain it has a good or a bad reputation. And then the piece that has really the most functionality in terms of enabling and securing your credentials is the user intel service. So you can look for things like IP address, email address, breach passwords, and we'll see that here in a second, and username. So that's particularly interesting. So the console, I said the console is very nice to use, very intuitive. You see at the top there, this was yesterday, I did the screenshot. I still have a credit of $2.39. And I did, what do I have there? 837 API calls for the user intel. Domain intel, I haven't tested that as much. I have API calls there as well, but it's very nice. Console gives you access to, as you see at the top next to the credit, the Slack channel, which there's a Slack channel, and everybody on the Slack channel has been very helpful and cooperative in terms of being able to help out and ask questions on. And then the API documentation is also available off of the console, and you can log on to it. You can do test API calls from the I guess the Open API interface on it, so you can do testing on it, which is very nice. And that's the way to get started there as well. So again, that's what the Pangea console looks like. You would create an API key to be able to use it. So there's two pieces of information that you would need in your program or in the collection. The domain, and you can see I highlighted there, the domain is aws.us.pangea.cloud. It's the geography is US, it's in California, and then a token. So you can have, the tokens can be very granular. You can have a token that's used by multiple services or a token per service, and you would have that, you would create that token and you would have a domain associated with it. They are the two pieces of information that you would need to provide as credentials or access to be able to do the API calls. So before we jump into the content collection, anything Pramod there that I missed that you want to add to? Certainly you can. Did I cover that, or is there anything you'd like to just?
I think you did a fantastic job. I actually learned a few things. I will say, Joel, it's Pangea.
Okay.
Instead of Pangea, but Pangea. And we are coming up on our 2-year anniversary at the end of this month. So
okay, well, my wife frequently corrects my
it's okay.
because I use a lot of Pennsylvania Dutch terminology.
Is that what it is? All right. And yeah, no, great job. I mean, I usually characterize Pangea as the Twilio or Stripe for security, right? Again, making it very easy for app developers to integrate security features as they think about secure by design. With essentially one line of code, you have the various features you need. So whether it's a simple app that requires security essentials, or if it's an application that might be health tech or fintech or another highly regulated segment, we have that as well. So,
okay,
yeah,
very good. Sorry about the pronunciation, but
oh, no worries. I just
I make up words too, so
I hope you don't mind me correcting. So yeah,
no, that's okay. So I published this Ansible collection. I published it on Galaxy, so you can download the collection. And I said it only covers a subset of all of the API calls, but it's there. You can look at it, you can use it, you can test with it. So that's out on Galaxy, and just to give you an idea of what that might look like, this is an example of where we want to look up a breached user phone number. So this is just a Ansible playbook task, 2 tasks. It calls the collection. The ops there are the domain and API key. I have an action. In this case, it's action user for user intel. I've passed it some parameters, the phone number, and then raw provides the raw information. That's a Boolean true or false. And then I register it, and I can go back then in the next step in this particular playbook, and you can look at the output of that and process it, whatever. So a lot of these examples, I just do a debug so that you can see it. And that's where you could take that content collection and do whatever with that output that you wanted as subsequent steps in the playbook. Look at it, read it, reformat it, what have you. The companion repository for the meetup. So I created a second repository that can be that's available, that you can use VS Code and Docker Desktop, and it will install the content collection through the collections requirements file, and then also the requirements.txt file in there, so that it will install the Python packages that you might need for that. And I have some sample playbooks out there. So there's sample playbooks to check passwords, to use this router plugins, to decode and look for secrets in a configuration file. And then I added one more thing to do the netbox contacts question there. So if you get nothing else out of the session here today, these sample playbooks are a good reference for doing a few things. Number one, examples in how to develop and use a filter plugin with Ansible. How do you append to lists in a playbook? How do you create dictionaries across reference? You'll see why that's important in a minute. And then how to do conditionals and anchors in a playbook. So they're playbooks that do some data manipulation in there as well. So that's available. You can go out and look at the README on that. You could do a git clone on that. Start VS Code up, create an account in through the console, and put your API, create an API key, put your API key in, and you can do all of these things at really at no cost to get a feel for it. So just want to talk a little bit quick about hashes and ciphers. This is kind of important in how you use some of these. So why do we care about all this? Why do we care about security in networks, and why do we care about security in our network source of truth? Well, Cisco router configurations are a source of a great deal of information about an organization, and many times as network engineers, network operators, we see people being very cavalier about where they leave these things lying around. Sometimes they're not always in a secure location, or sometimes if someone has infiltrated your network, they may be able to get in the Cisco device. And what are they going to do if they get in a Cisco device? They'll do a show running config, and there's all kinds of sensitive information that we store in these configurations. Credentials, community strigs, some of them are encrypted, some of them are simply hashed, some of them are in plain text. So the idea is that we need to really think about the credentials that we put into these devices, and be able to use, ideally, usernames and credentials that have not been exposed in a breach, or if they are, we just need to be aware of that. So there's a wealth of information that is personal identification in network devices that we need to be aware of. So just as a reference, the Cisco password types have evolved over the years. Type zeros in clear text, we don't use those anymore, or at least we hope we don't. Type 4 never really made it off the ground. Type 5 is an MD5 hash. We'll see why that's important here in a minute. Type 7s are pretty easy to crack per se, and actually I took the logic, some type 7 logic, and put in a filter. So I actually have logic in that filter plugin that, given a type 7 password, it will convert it back to clear text, and then run the clear text through the API, through that Intel module, to be able to see if that clear text password was a part of a breach. And then you also see type 8 and type 9, which are more difficult and more recommended there as well. So if nothing else, you can take the plugins that I wrote, go through router configuration files. You can pull out passwords, you can pull out usernames, email addresses, and use it as a way to very quickly identify what things may need to be shorn up a bit in your router configuration files. How we have to address the password breaches, and this was new to me. This was something that I learned through help of the Slack channel. The way the API call works here is you have to do a SHA-1 or a SHA-256 hash of your clear text password. It does not support MD5. So I mentioned earlier that the type 5s are MD5 hashes. You have to be able to get the clear text of that. The type 7 is easy to do. MD5 is a little bit harder because you would need to do a dictionary attack against it. But the way this works is that you take your password, you do a SHA hash of it, and you send the first 5 characters of that in through the Python SDK, and it goes out to the provider in the back end and brings back a subset, or brings back a set of all of the breached passwords and all of those hashes. And then what you do with it is you come back and you take those and compare that against the hash that you created prior to doing the API call, and you pick out of the subset the breach count of that particular hash. So the terminology, and this was something that I learned about, is this K anonymization, which is basically the concept of hiding in the crowd. So rather than send a hash of a full hash of the password that you want to check against these providers, the dark web, so to speak, you send the hash in just the first 5 characters. It's going to do because of the fact that that hash is going to overlay, or hash is going to have collisions against a lot of different ones. You'll get an answer set back that may have 100 different hashes, and then you go in and index into that to be able to see if your particular hash has been breached or not. So we can see an example of that. I have a code example of that in the Ansible playbook that does that. And you can do that in an Ansible playbook. It just requires a little bit of data manipulation and creating that cross-reference dictionary that I mentioned earlier. So we have examples of that. And here's really what it looks like. So we go out, when we want to check for a breach password, you can either use like the SHA-1 sum command in Linux, or you could use Ansible's built-in hash plugin. You create a hash of your clear text, you send it into the API, and when it comes back, you'll see that the raw data that came back returns a dictionary with the hash as the key and the count as the value. So now that we have that, we have created that full hash that we sent in, and only sent the first 5 characters of it. It comes back, and you'll see here at the bottom of the screen that output of this particular playbook, we sent in the first 5 characters, but we get the full hash back, and then we get a count back. So in this case, people have for years used Cisco 123. We used to do it all the time at Cisco in our documentation. Cisco 123 is a password, and you can see that when we hash that in SHA-1, send it to the API, get the answer set back, there's 39,625 places where that appeared in a breach as a breach password. So that's a lot, but that's what you would expect for a common password that we use in Cisco routers. Any questions on that before we move along? That's something that was new to me. It might be new to a lot of people. Okay. So, yes.
So that's matching on those first 5 characters of that hash, right? And
That's right.
And so then you could does it return all of the hashes that it found that match that? Correct. Okay, and then you would like locally pair those to see if it actually matched.
Correct.
Okay.
Right. So we do the hash in the playbook. We retain the full hash. The module that I wrote, I apply the full hash into it, but the module that I wrote does a subset, the first 5 characters, sends that to the API. The API, because there's going to be a collision on that, because it's only the first 5 characters, sends back the answer set that has made, let's say 200, and that answer set contains the hash as the key, the count as the value. So then I can go, because I have the original full length hash, I can index into that result and say, okay, I have 39,625 hits, so I can index into that. And Bob, if you want to run if you want to download this and run the playbook, kind of look at the playbook, it'll make more sense. But that's why you have to essentially create in Ansible playbook, create a dictionary of that result so that you can index, or you index into that dictionary that result. So it's a way of hiding in the open. In other words, you get so much answer set back that anyone that's monitoring your communication wouldn't know which one of those you're actually looking at, because there might be hundreds of them. So some use cases. To demonstrate this concept of auditing our router configurations, I have these lookup filters. And if you're not familiar with Ansible plugins, a filter is a data manipulation. So these filters, I read a configuration file and I pass that into my filter, parse IP, parse email, parse URL, parse secrets. So I can potentially pass in a complete router configuration file into the filter, and I call the filter name, and the filter is going to go back and pull out any IP addresses that it finds in there and returns a list of unique IP addresses, IPv6, IPv4. The filter module that I wrote, or the filter that I wrote, I exclude special use addresses, so I don't return 10 dot addresses, because they're going to show up. They're internal. They're not going to be routed on the internet. So I filter those out. Same way with secrets and URLs. So router configurations, as we'll see, as an example. So this is actually an example of an 837 router config that I had when I was doing VPNs, teleworker VPNs at Cisco a few years ago. I happen to have one on my personal machine here. And you'll see there's all kinds of information in there. So we might have remarks. I was one for putting remarks in ACLs. And I changed these around to protect the innocent, but a lot of times I would have a subnet owner or a network management owner. I would put their email address in the remarks so that I knew who they belong to. And you also have URLs. So you might have aliases that do WRNet for a copy run to TFTP, save config. And I kind of mocked these up for the demo, but just looking at that router configuration, there's all kinds of email addresses, there's all kinds of IP addresses, there's all kinds of URLs that are exposed to these. So it'd be nice to see if these are all legitimate. And then here's an example of that. So in this case, if I want to audit this router configuration for IP addresses, so on the left is what the playbook would look like. So I loop through that input file with the IP addresses that it returns. So it's going to return, as you see on the upper right-hand side, in that particular router configuration, my plugin filter returned all of the public IP addresses as a list of IP addresses. So I go through and send them into this Intel module, and then I'm going to get the results back, and I can go through from those results and say, yep, that IP address was found in a breached data set. And that's what you see in the lower right. So in this case, I had an NTP configuration for a tick and talk from the NTP server at the Naval Observatory, 192.5.41.40. So that's a public IP address. And you'll see that when I did the user intel, that was found on a compromised user's machine in this case. So it's a user intel that those IP addresses were identified in that particular user. And then so we have the other filters as well. So that just gives you an idea of how you can take those configs that are maybe laying out on an FTP server someplace, and fairly easily and fairly inexpensively go through and and run an Ansible playbook to get some user intel about whether those IP addresses, those email addresses, or those URLs were subject to a breach, to see where they might have been picked up. And this is just an example of URLs. So I used the dummy URL in here that I knew was going to find a hit. So in this case, that parse URL filter found those three URLs in that router configuration file. And in this case, that URL is one of the test URLs that's in the user documentation. And you'll see that it came back and it was compromised with that URL and port number. So whether that is legitimate in my router configuration or not, I don't know. But often we have a number of engineers that are doing router configurations. And we also, in many cases, we have networks where we have acquired other companies and we've acquired their router configurations. And the person owning that configuration may or may not identify or know, what those URLs or why they're there. So that's just one way of looking at, that intelligence, that identifiable information that we might find lying around in router configurations. This is a way of understanding them and getting a little intelligence about it from a programmability standpoint. And then email addresses. So I put John Chambers in there because there's a lot of hits on his email address, chambers@cisco.com, even though he is no longer there. And I thought it was rather interesting. That Spy Cloud is the publisher. And you'll notice that the date there is March 14th, 2023. So that's fairly recently. And I had a laugh at whoever created this or whatever it was exposed to. I don't think that date of birth's correct. It's probably close to the right year, probably not the right date. Somebody was phone number looks correct. That looks like a 408 phone number. So that's probably Cisco's main switchboard phone number. But it's just amazing the information that you'll find out there in these breach data sets. And then earlier this week, a couple of days earlier, I thought, well, we looked at router configuration files, but that's kind of old school. So if we have a netbox configuration, and in this case, we're working on a project for a client who is a service provider that uses netbox, and they have thousands of tenants because they're a service provider in netbox. And each of these tenants might have some contacts. So in this case, our test data that we have in our netbox cloud has a series of contacts, names, email addresses, phone numbers. Well, why not see if they're exposed in breaches as well? So by using the GraphQL interface to netbox cloud and doing that simple query, contact list, email, name, and phone, pull that out in an Ansible playbook, call the user intel module that I wrote, and identify if any of these phone numbers have been, or usernames, email addresses, so on. I just show the phones in here. So there's a sample playbook to do netbox contacts as well to pull that out information. And in this case, again, that's a phone number that I put in, I know is going to find a hit. So it did find a number of hits on that particular phone number. But often what you'll find, and we're going to see this in the next example, is people tend to use the same username and the same passwords in all of their different accounts. So one of the things that when I was doing some testing in all of this is I said, well, let me go out to NC State. So NC State actually has an online directory that's publicly available. And I put in the user, or the first name letter, first initial J, the last name King, and it came back with about 7 hits. And those 7 hits gave me the email address of 7 different people that started with their first name started with J and their last name started with King. And I just selected one of them. It was one of the professors at NC State, I think in forestry, I'm not sure what it was. And I said, well, let me take his NC State username and pass it into the user intel and see what I get back. So, you know, first thing that you do, you get a new account, you start a new job, you go to school. Your username may be the same because people tend to use similar algorithm or similar concept in creating usernames. And a lot of times people reuse the same password. So ran that through and it was interesting. It came back that his username looks like he might have had a Roadrunner account in Cincinnati at some point in time. And if you'll notice, it comes back with a plain password plain text. So I was guilty of that as well. I had, when I ran some of my email addresses through this user intel, I found some intelligence with plain text passwords. And that's what I like to send to my buddies is like, hey, I know your email address and here's your password that you used maybe 7 years ago, but I hope you're not still using it. So it's very enlightening. It's very enlightening to see that. So the idea being is that how this would be important. So I said, we've been working on a project and a lot of what the Blue Ally Consulting or Net Craftsman does is unified communication upgrades, call manager upgrades. And one of the things that we're looking at is how do we automate the CRUD operations, adding users' phone numbers, email addresses for clients. And ideally, what you'd like to do is drive that through your ServiceNow or your ITSM system. So you have an email user and you're adding that to Call Manager. Why not just go out as part of that automation process and see if those users that you're adding to your Call Manager have been breached and provide that information back to the user that you're onboarding into your system, because if their password has been breached and they are using the same password that they used in that breach data set, it creates a security exposure for your organization because now you have somebody that potentially is a target. I've been able, you know, obviously NC State published, and this use case, by the way, is not NC State. I just picked on them because they had an exposed directory. But if those people are using that same password that they used 5 years ago, and they have a new account at this organization, it really opens them up to being able to be exposed because that information was breached at a previous location, or it could be a personal location. So this is just an example of that example playbook. It's pretty straightforward. I have a breach user check that you can run out there. You can pass in an email address, a phone number, or username. And for demonstration purposes, what I've done is take the answer set of that back, convert it to YAML, write it out as a file, and then I email it just so that you can see it. And there's a little demo of that we have here that I'll give you the link to. So obviously you'd want to maybe format that information. Perhaps you'd want to create a ServiceNow ticket or add to a ServiceNow ticket or send it to your SOAR platform if you find that to be able to remediate that. So that use case, I think, is very valuable, and it is very inexpensive to do because the cost of the API calls to do that against the cloud instance, you know, it is trivial compared to the exposure that organization may have by setting up users in their system that have breached credentials from a past life or a past company or past institution that they may have worked at. So little video demo on Vimeo. Nick will put these slides up. It's just a little 3-minute video that you can look through that particular use case. And yeah, so from a collateral standpoint, I have, I said I have this collection that's out on Galaxy, and that includes a module at intel.py that does the domain, the URL, and the user intel. There's 2 sample playbooks on the GitHub repository that that it was used to build that Ansible collection. There's a breach user check and an Intel test, which just basically shows you how to call that module in a number of different scenarios. And then for a meetup, I created this GitLab repository on my account that has these Cisco router filters and the type 7 password decoder, and then these sample playbooks, a check password, a Cisco router, Cisco secrets, and then the next box context. And I said they're not production ready because essentially they just do a debug output, but they'll show you how to use it and you can build upon it, and you can kind of go from there with it. So with that, I'll I said we're going to keep it here to about 40 minutes or so. With that, I'll kick it open there for any questions or comments or anything else you'd like to ask about. Whether you like these use cases, you like these ideas, or not. But let's just talk through it a little bit. I think everybody is on mute, so if you want to ask a question or whatever, you will have to come off mute.
Joel, I'm curious. Have you tried running this against accounts that you know have been practicing good network security practices? You using a password repository, using separate passwords on each system, things like that?
Yeah, and obviously for testing, I use passwords that I know were probably commonly used because they were in documentation, like Cisco 123. But what I'll do in the future is, before I create a password, now I have my own password manager that I wrote and that I run, and I keep my passwords, encrypt my passwords on my systems. But yeah, you'll find things that aren't hit. I mean, for example, Cisco 123 had 39,000 count of 39,000 breaches. If you do Cisco 123 comma, it might have 7,000. So as you get better and better passwords, ideally, before you create a password on a system, it'd be nice to run it through and see if it's been exposed. And if not, then it's probably, it's either not been exposed or it's a better password that's more difficult to expose.
Any other questions from anybody in attendance?
Do you see other use cases that you might have? So, I mean, obviously, onboarding a user in Call Manager, or creating accounts on servers, creating service accounts on routers, anything that you're creating an account on, it would be worthwhile to kind of check it. And obviously, we've been doing that for some time, so we have a lot of old user IDs, and we're all guilty of not changing and recycling our passwords as often as what we should, until we get a notice from a place like like Discover Card or somebody like that, or online marketplace saying, hey, we've been breached, you probably ought to change your passwords, which seems to happen quite a bit anymore.
So how does this play with the new multi-factor authentication mechanisms, where it's not just password anymore?
Well, that obviously, that's a good thing, because that gives you one more layer of protection. But the challenge is not everything's readily enabled for multi-factor. And multi-factor, depending on what the user is, if it's just an SMS message, people have been exposed to, what do they call it? SIM takeover? Is that the right terminology? SIM takeover? I saw something recently where somebody calls up Verizon, AT&T, or whatever, and says, hey, I got a new SIM card. You got to change the SIM card. And all of a sudden, they're getting the messages from their target as opposed to them. So
Yeah, I call it hijacking.
yeah, SIM hijacking, right? SIM hijacking, I think, is the right term. And things like Okta and some of those other things that have a client. Google has one now. I think doesn't Apple have one too, where they have their own clients for doing multi-factor. Yeah, I mean, multi-factor is good. You should use it as much as possible. I use it on any sort of financial accounts that I have that I can enable it for. So Bob, you since you asked about the hashes there, I'll give you an assignment there. You play around with it and report back to us what you think of that.
I mean, I think it's interesting, and I think kind of what we see as we get into, as we've seen more adoption of automation and enterprise and across all verticals, is that iteration of it. And so I can certainly see having this as part of a deployment sort of pipeline, checking S&MP or whatever, obviously user accounts that would be on a router or switch or whatever we're deploying. It's just something that makes sense.
And the beauty of it is the cost of doing it. If you go into the cloud portal and look at the cost of doing it, I say you get a $5 credit for development. But even if you run, a couple of hundred or a couple thousand API calls, it's trivial compared to the exposure that you might be preventing. That's the thing. The cost benefit analysis of it is really good, because I've given you some samples. The code was pretty easy to write. I think I wrote the Intel module in like a day and a half. It was, I mean, the documentation and all the other things that go along with that's what takes the time. But it's pretty easy because you have a Python SDK, and it's pretty easy to take what I've done and build upon it, or modify it or add different things that you have an example. And the cost of doing it is very low. The value potentially, and it's an intangible, because you don't know. I mean, you never get credit for the breach that you didn't have, right? It's only the breach that you did have that gives you exposure. But I mean, the cost of these breaches anymore are in the millions and millions of dollars. So being able to do best practices and stay out of the news is always a good thing. Well, okay. Appreciate everybody. If you have any comments or questions, you could hit us up afterwards. Nick, thanks again for setting all this up, doing the live stream. And
happy to do so, like always. I dropped the link in the chat. It's wwt.link/meetup. That'll take you to where the content will be posted. As soon as I get the recording back from WebEx, I will get this up there along with the slides and the links to all of the repos and Galaxy that Joel shared at the end of the presentation. Live stream was also captured on the Programmability Meetup YouTube channel. And so we're live there, which I'll end in just a second. But thanks to everybody. If there's anything that you want to present on, or anything you're working on that you think the broader community would be interested in, always looking for presenters as well. So please reach out if it's something that you're interested in doing. And with that, we'll end it and get everybody on their way, and have a great day.
Thanks, Joel.
Thanks, Nick. Thanks, everybody. Thanks for attending. Appreciate it.
Thanks, Joel. Good job. Thanks.